First of all, credit where credit is due. I took this content, including the pictures that I've used, from this link from AWS. There's an ebook. So that's where all the content was taken from. Let's start by defining what is DevOps. We have been doing DevOps, but this is one of the things where the definition varies. People talk about these terms, but the definition is not clear and the interpretation is actually different from person to person or team to team. So DevOps, based on how I have understood it, is basically a merger of philosophies, best practices, automations, and tools. So it's a merger of DevOps is not just automation. It's not just using a specific tool. DevOps is not just using Jenkins or using code pipeline for CI/CD. DevOps, I think, is a way of life. It's a mindset. It's a way of doing things. So for example, instead of deploying by hand manually, you always deploy through CI/CD pipelines, so on and so forth, right? And the main objectives, yes, in DevOps we have CI/CD pipelines, automations, and all of that nice stuff. But the main objective are to deliver faster with fewer errors, okay? And the other thing is to be agile. You know, teams are agile, they are using agile processes, but in order to be agile and to support the agile processes, you need very strong DevOps. Otherwise, you cannot have short release cycles, you cannot release often if you don't have strong DevOps. So that is very important to be truly agile. And eliminate silos. Obviously, the main challenge which DevOps solved is to bring together the operations and the development teams. So traditionally, they were working in isolation. DevOps brings them together, hence the word dev and ops, right? Now, before we go into how we achieve modern DevOps, we need to understand some of these principles, okay? So the first thing talks about practicing accountability. As I said, DevOps brings the two teams together. And once they're together, they have shared responsibility and accountability. So instead of operations just focusing and doing the ops and development team just being focused on development, we bring these two teams together, and then they share the responsibility of solving the problems and developing and deploying successfully. That is what we want to solve, right? So bringing these two things together. Okay, so that's the shared accountability and responsibility that is shared between the two teams. And the other principle is to be able to measure yourself. Some of these are obvious best practices, which we also incorporate in other work. But for example, when you're incorporating DevOps, first identify the areas for improvement. What is your current release cycle looks like? How long does it take to release? You know, do we run in a lot of merge conflicts? Do we run into any deployment issues? And if it takes a very long time, what parts take a long time? So, measure that, and then we would know, okay, what parts to improve, and then we can measure our performance. Once we improve them, we can measure if we are improving this system. Okay. Another principle is to make incremental improvements. This is once again same as in other projects, and so it applies to DevOps as well. Instead of trying a big bang approach where you are trying to achieve all the improvements in one go, and we basically make smaller steps, baby steps, make incremental improvements in order to get us to where we want to be eventually. And then automate everything. Obviously, one of the core tenets of to achieve strong, efficient DevOps is to be able to achieve as much automation as possible and remove as much human intervention as we can. Another principle, and very important one, is to codify wherever possible. You all have heard about infrastructure as code. That is the prime example of this principle. So wherever we can codify, we incorporate codifying. For example, infrastructure as code, as you know, is your entire infrastructure as code. And this allows us to version control and have the same process that we follow for application source code. Okay. This allows us to reuse the code and also revert back to any of the previous versions. So all of the nice stuff that comes with having things as code. And the other thing is policy as code. So your governance, compliance within the organization, that could be code too. Instead of using spreadsheets, that could be code. Once again, version controlled and also automate. Implement belts and suspenders. It's a term basically used for two main things. One is encouraging best practices, and then the other thing is enforcing best practices. So an example of encouraging best practices using IaC, where once you have the templates for IaC, you could just reuse them in other projects, which we are all doing now. And then in terms of enforcement, once again, policy as code is a good example of enforcement, right? So for example, if you want to enforce specific configurations to be compliant with, let's suppose, HIPAA or something, you could have that policy as a code, and then that you can automate those checks. AWS config, by the way, this is what it does. It's a good example of policy as code. The third thing is using AI to identify issues before they even happen, right? So that is the next frontier in modern DevOps. The other principle is standardizing tools. You just saw a very nice demo of Jenkins. We have used AWS tools, AWS Code Pipeline and Code Build. And there are so many other tools, right? Circle CI, Bamboo, so many other tools that does the same job. In order for the company and the teams to be efficient, we need to standardize the tools so that we can work in harmony and also use tools that work well together. So, okay, so now the principle part is done. Now we're going to talk about the action plan, which is going to be more interesting. So how do we implement modern DevOps? First concept is GitOps. GitOps is basically the process it's basically following the same process that you use for your application source code. So it takes IaC a step further. You have IaC, but now your IaC is going in a Git repository. And then once you push changes to the Git repository to a specific branch, the standard process, right? It's going to go through a PR, and then once you push to a specific branch, CI/CD pipeline is going to pick it up and automate the deployment. The deployment in this case is going to be provisioning or update or deprovisioning or of infrastructure, right? So you get the benefits of storing everything in source code, having the entire infrastructure as code, and automating the provisioning of the infrastructure. Within AWS, you could use these tools to implement GitOps. One is CloudFormation, obviously, for IaC. The other is CDK. and code pipeline, as you all know, to orchestrate everything, code build for the individual phases of the pipeline, and then code commit for Git repositories within AWS, and also we have integration with other popular providers like GitHub, Bitbucket, GitLab, etc. Okay.
So one question.
Yes.
Regarding GitOps, so it's covering both CI and CD both, or it's covering the CD part only?
This is more focused towards this GitHub. From this perspective, this is focused on the infrastructure. You can separate the two, but this is not the application source code. This is just your infrastructure. It's for that. Within infrastructure, you can say, okay, there's a CD part, there's a CI part and CI part, right? It's the same thing that you're going to have with your source code. There's CI is separate and CD is separate. So it's the same thing applies here. But this GitOps, this is more of a process where the only way you push infrastructure changes is through by pushing changes to the Git repository and through a CI/CD pipeline, okay? So that it's properly version controlled, and the advantage you get out of it is whatever current infrastructure you have, it basically came through only one process, right? So it's a controlled way for infrastructure provisioning.
I think we can include integration in it as well. Like we can, in the build phase, we can for CloudFormation, we can validate the template. Like it could be a stage in CI/CD pipeline.
Absolutely. So just like what you do with your application source code, which is you could run SAST, you could do any static analysis, you could run any testing on your IaC templates. Okay. For example, SonarQube supports scanning IaC templates now, CloudFormation templates. So you could run SAST on that. You could run code quality. So the same processes that we use for our application, now we can use it for our infrastructure provisioning as well. Okay. So compare it with the process of just manually going in the consoles and making infrastructure changes, right? So you compare it with that. This is much more elegant and smoother way to actually make infrastructure changes. You can roll back to any of the previous versions. It's being version controlled. You can see the history and all of that, right? So, okay. Next thing is AIOps. Okay. So this is where I was saying one of the principles where now we start using AI for DevOps. Okay. So one of the example, but first, how does it help, right? So if we use AI, then the reliance on developers and DevOps engineers' knowledge is going to decrease, because now we are relying on our ML models that have been built from the years and decades of operational data that we have for operational AI and for code reviews, right? We are relying on the past data. So now it's going to supplement or augment the developers and DevOps knowledge in finding issues proactively. Okay. So for example, SonarQube does this too. Within AWS, you have the Code Guru Reviewer that is going to do automated code reviews of your PR. So just like we put comments, Code Guru Reviewer is going to put comments on our PRs, any issues that it may find in terms of security, code quality, okay, refactoring, absolutely. So that's a very good example of AIOps for code reviews. And this way we are able to find issues before they even occur proactively, okay? And this is what AI is all about, right?
It basically runs something, or it's basically implement something?
Yeah, so you have for these, right, you have machine learning models built based on the past data. And now it's using that knowledge by reviewing your code, and if it matches any of its patterns, it's going to say, okay, you have this problem, this potential problem in your source code on this line. Okay. You also have a Code Guru Profiler, which basically profiles your running applications in production or any other environment, and it is going to tell you about any performance bottlenecks, right, which are very hard to find. Sometimes they could be very hard to find. Can tell you about your performance bottlenecks or where we can improve the code and make it faster. Then you have the DevOps Guru. DevOps Guru is AI for your for operations. Okay, so it is going to monitor your infrastructure metrics, like your response times, error rates, latencies, and based on the decades of knowledge it has, is going to tell of any potential problems that could happen before they even happen, right? So that's another thing that we can use in our DevOps practice. And with DevOps Guru, it's like a very simple one-click deployment. So we should include it. You know. Okay. So continuous observability. This is something which we have done in all our projects. You know, it's just a matter of identifying and documenting it. So continuous observability is basically having the ability to identify the state of the current state of the system at any given point, and also be able to investigate issues and remediate problems efficiently. Okay, so an important first step for this is to be able to build observability dashboards, which, for example, we do with CloudWatch, but we could also do with Datadog, Grafana, Prometheus, and other tools, other popular tools that are out there. ELK, right? Next part, obviously, like I said, this is something which we do in all projects, just a obvious thing, just but the next phase would be to create alarms if anything goes wrong. So within AWS, we use CloudWatch to set up alarms and then send notifications to stakeholders. So that is what continuous observability is all about. And also, it is about structuring the logs. And for example, also we could have traces. We could have application performance monitoring. Datadog has that. With AWS, you get it from X-Ray. So structuring the logs and traces and everything in a way that it's just easier to identify, investigate issues when they happen, right? Rather than spending hours and hours. Once we have structured these things, log ingestion. Okay, your logs are being ingested, but how are we going to be able to view the logs? How can we efficiently search within logs when an issue happens? And all of that nice stuff, right? These are the things we need to think when we are building the systems from a DevOps perspective. That how can we easily have all these things that work together and help us investigate issues when they happen. Another action plan item is continuous compliance. So traditionally, compliance used to be spreadsheet, right, or checklist. But now with cloud, everything is moving so fast that method cannot keep up. So we need continuous compliance, which obviously I talked about policy as code, and that's one part of the implementation. And also being able to check for compliance and governance in an automated way. And the Institute of Internal Auditors suggests structuring risk through the following three layers. One is risk management. Within AWS, for risk management, you have AWS config, where all your compliance check are available as templates. You could write your own templates as well, and then you could use AWS config to automatically check your AWS services for those checks. If they are not compliant, you're gonna you can set up alarms. You could receive notifications. Then CloudTrail, as you all know, it helps with like a full end-to-end audit. And then you have services from Systems Manager as well, like a Patch Manager that you could use for to manage risk. The other thing is oversight. So for that you have Security Hub. Security Hub is built on top of AWS. It uses AWS. And for example, it can check for various best practices, various standards to make sure that those are being incorporated. If not, you're going to receive a report which checks are not passing, and then you can work and remediate those. And then obviously you have CloudWatch to monitor the logs, have any custom metrics. And the third is risk assurance. For that, within AWS, you have the Audit Manager that you could use for evidence collection, and actually automates evidence collection. It scans your account and automates the collection of various evidences.